Bismillahirrahmanirrahim. Dear students, you are watching educational channel KMCH. I am Khalid Mahmood from KMCH Physics Academy. Our subject is physics of class 9th. We are solving its MCQs. Today we have to answer MCQs of unit number 5, which is gravitation. Question number 5.1. Encircle the correct answer from the given choices. Question number 1 is Earth's gravitational force of attraction vanishes at. Option A is 6400 km, option B is infinity, option C is 42,300 km, and option D is 1000 km. Equation number 5.6 in our book is G is equal to capital G me over r square. It gives the value of G. So in this equation, G is proportional to 1 over r square, or we can say G is inversely proportional to r square. R square is the radius of the earth. So the value of G will decrease as r will increase, but it will not vanish until this r becomes infinite. So when r becomes infinite, then the value of G will vanish. So our option at B, infinity, is correct option. Earth's gravitational force of attraction vanishes at infinity. So we will fill this circle in front of option B with black ink. Question number 2. Value of G increases with the options are A. Increase in mass of the body, B. Increase in altitude, C. Decrease in altitude, D. None of the above. So equation number 5.8 in our book is G at height h above the surface of the earth is equal to G me over r plus h ka square. Here h is height above the surface of the earth, that is, it is altitude. So with the increase of h, G will decrease, and with the decrease of h, G will increase. So value of G increase with the decrease in altitude. So our option at C is correct. So we will fill the circle in front of C with black ink. Question number 3. The value of G at a height 1 Earth's radius above the surface of the earth is. Options are A 2G, B 1 over 4G, C 1 over 3G, and D 1 over 4G. You know G at altitude h is equal to G me over r plus h ka square. If this altitude is equal to radius of the earth, then gr is equal to G me over r plus r. This h will be replaced by r. So gr is equal to G me over r plus r 2r ka square. Gr is equal to 1 over 4, 2 square of 2 is 4, Gme over r square. This Gme over r square is the value of G. So Gr is equal to 1 over 4G. So our option at D is correct. So we will fill the circle in front of D with black ink. Question number 4. The value of G on moon's surface is 1.6 meter per second square. What will be the weight of a 100 kg body on the surface of the moon? The question is, a body having mass equal to 100 kg is at the surface of the moon, and where value of G at the surface of the moon is 1.6 meter per second square. We have to find the weight of the body at the surface of the moon. Our options are A 100 Newton, B 160 Newton, C 1000 Newton and D 1600 Newton. Now we know that if we know the mass of a body, then weight of the body W is equal to mg, where g is acceleration due to gravity. Now mass of the body is 100 kg and g at the surface of the moon is given 1.6 meter per second square. 100 into 1.6 is equal to 160. The unit of weight is Newton. So weight of the body will be 160 Newton at the surface of the moon. Our option is correct at B. So we will fill the circle in front of B with black ink. Question number 5. The altitude of geostationary orbits in which communication satellites are launched above the surface of the earth is. Our option A is 850 kilometer, option B is 1000 kilometer, option C is 6400 kilometer and option D is 42,300 kilometer. The height of a geostationary satellite is about 42,300 kilometer from the surface of the earth. Its velocity with respect to earth is 0. So our option is correct at D. So we will fill the circle in front of D with black ink. Question number 6. The orbital speed of a low orbit satellite is A. Option 0, option B 8 meter per second, option C 800 meter per second and option D is 8000 meter per second. Now the orbital velocity is given by V0 is equal to square root of gr, where r is the radius of the earth. For a low orbit which is very near to the surface of the earth, we can make an approximation by taking its orbit equal to radius of the earth r. So putting values in this equation, g is equal to 10 and r is equal to 6400 kilometer. So it will become 6400 into 10 to the power 3 meter. So taking square root, we will get 8000 meter per second. So our option at D is correct. The orbital speed of a low orbit satellite, that is which is very near to the surface of the earth, will be approximately 8000 meter per second. So we will opt this option and we will fill it, the circle in front of it, with black ink. So students, this was the chapter 5, gravitation. We have solved its MCQs given in its exercise. If you like this video, please like it in the YouTube option, and if you have not subscribed my channel still, you may subscribe it. May you live long. Thank you. Allah Hafiz.